This is the self-assessment of section 5.2 in Algebra 2. So just going over some review from our notes. So if you're doing 2 to the 3/4 times 2 to the 1/2, because they have the same base of 2, you can add the exponents. So you can do 3/4 plus 1/2, which is 5/4. So your answer is 2 to the 5/4. Okay, on B, because these are both to the 1/2 power, you can kind of undo where we distributed that 1/2. So you can put the 1/2 outside and you still have 20 over 5. So 20 over 5 is 4. 4 to the 1/2. Remember that a 1/2 power is like a square root. So the square root of 4 is 2. All right. On 2a, we cannot currently add these because they're not like radicals. Yes, they're both in a cube root, but you can only add or subtract if they're the same root, but also the same number inside the radical. So we need to break down the 40. So I'm going to break down 40. 40 is 2 times 20. 20 is 2 times 10. 10 is 2 times 5. Remember, since it's a cube root, we circle groups of 3. So the cube root of 40 breaks down to 2 cube root 5. Now they are both cube root of 5, so they're like radicals, and you can add them. If you have a cube root of 5 plus 2 cube roots 5, you have 3 cube root 5. On B, you cannot have a radical in the denominator, so you need to multiply by the conjugate. So instead of multiplying by 6 minus square root of 2, you change it, the conjugate is 6 plus the square root of 2. Now, you have to do that on the top and the bottom because that's multiplying by 1, which is what makes this allowed. Do not multiply the 3 yet. Wait until you find out the bottom number to distribute, because if you need to simplify, it's so much easier to simplify before you've distributed. All right, I'm going to multiply 6 minus the square root of 2 by 6 plus the square root of 2. So 6 times 6 is 36. I get negative 6 square root of 2 and positive 6 square root of 2. Those cancel each other out, which is the purpose of the conjugate. Now I have negative square root of 2 times square root of 2. That's negative square root of 4, which is the same as minus 2. So 36 minus 2 is 34. Now I check and I see if 3 over 34 can simplify, which it cannot. So then if it can't simplify, I'm ready to go ahead and distribute. So 3 times 6 is 18 plus 3 square root 2 over 34. And that is my solution. All right, on example 3a, we're simplifying. So we want to simplify. If I think of 36 and I break it down, it's 2 times 18, 2 times 6, and 2 times 3. There's no way I can circle 6 of the same number. So my 36 is just going to remain. It does not break down. P to the 6th is perfectly good because it's the same as the root. So I have a 6th power and a 6th root. Q to the 8th, I'm going to break up. I'm going to have Q to the 6th and Q squared. It still adds up to 8, but I pulled out 6 of them. And then R to the 10th, I'm going to break up into R to the 6th and R to the 4th. Still adds up to 10, but I pulled out 6. Now, these ones that are divisible by 6, these are the ones that are going to simplify. So if I have the 6th root of P to the 6th, that's just P. The 6th root of Q to the 6th is just Q. And the 6th root of R to the 6th is just R. Then left inside the 6th root, I have 36 Q squared R to the 4th. Okay, looking at B, our final one here, I have a large 5th root of a fraction, so I can write the top as its own 5th root of x to the 10th, and the bottom, the denominator, as its own 5th root of y to the 5th. Okay. So the 5th root of x to the 10th, you can simplify that 2 ways. You can either think of that as the 5th root of x to the 5th times the 5th root of x to the 5th. That gives you x times x, which is x squared. The other way you could have thought about that is as it being x to the 10 over 5. Remember, power on top, root on bottom. 10 over 5 is x squared. So either way, you get x squared on top. I do not have to put an absolute value because remember that rule only happens when it's an even root of the same even power. So on bottom, I have the 5th root of y to the 5th, which is just y.